when alternating voltage is applied the primary winding, it draws a very small magnetizing current, and I sub P to village flux pi in the iron core. P primary winding, small magnetizing current I sub P, the iron core. Okay? So the alternating flux links the primary and secondary windings magnetically, and induce electromagnetic field EP and primary winding, and EMF electromagnetic field secondary in the secondary winding. Okay, magnetically induced EMF in primary, yeah, and this is the secondary. Okay, so EMF voltage is a P will be induced in the winding and will be equal to the applied voltage. Is a P if resistance of the winding is negative. So that was for, let's say, P. So P was answer P, and time differential is pi. Same thing. Sub S. P sub S. It was for P sub S. P sub S. So the drawing here, already. Yeah, that was, we assume that the iron core, and this is P sub P. This is V sub S. That was flux magnetic. This is what's magnetic primary side, magnetic secondary side. So I sub P, secondary current here. Okay, so P sub S is a turns ratio, primary, secondary, secondary, primary. That is for what we needed to the formula equations, the ideal transport. We assume that it is for the ideal cases. Example. Copy. Okay, here we go. So now from here, I'm gonna say this is the 18 minus 4j. Okay, this is the V sub 1, V sub usually E sub 1 and E sub 2. This is the primary resistor and capacitor inductance. So that was for V sub 1, 120 volt. The secondary was 2 plus j. Primary impedance be 18 minus 4. So from here, the primary side was 18 minus 4j. Secondary part 2 plus j. Okay, and then V sub 1 means V sub p is 120 volt 0. And this ratio that is the clue from the questions. Okay? So from the clue, we can get for the equation here, A and B. Okay, makes sense? You follow with me? Okay, so I sub 1 over I sub 2 is equal to N sub 2 over N sub 1. So from here, we're going to get I sub 1 is equal to 1 over 4 times I sub 2. And V sub 1 over V sub 2 is equal to N sub 1 over N sub 2. That is also what we have to do. So now, to the next slides, we have to KVL, okay, Kirchhoff's voltage loop 1 here. 120 volt 0 minus the 18 minus 4j, and I sub 1 minus b sub 1 is the 0. Why? Because that was step up, voltage drop, step down. There's also step down. So this is y plus minus minus. Okay, makes sense? And this is, we're gonna here. And from the equations here, we got b sub 1 is what? 120 volt minus 18 minus 4j, and I sub 1. Two. So here, like this one, four, four, I sub 2. Okay, that is equation here. Yeah, 2. What is it right there? Okay. So here, v sub 2 minus 2 plus j times I sub 2 is going to 0. And v sub 2, 2 plus j, I sub 2, right there. And here, this is, working here and here. Okay. And so summarizing, go to left side on the I sub 2. I sub 2. 8. Over 4. That is, we have already calculated before the turns ratio. T over transformer. That was 2.35 minus 13.5 degrees. Oops. That's it.